In this video, we're going to talk about something called an initial value problem. Before we do that, we have to define what we mean by a differential equation. Okay, so a differential equation is going to be an equation that relates some unknown function and one or more of its derivatives. So solutions to differential equations are actually functions. All right, so this is a little bit different than what you're used to. You're used to sort of having an x in an equation and trying to solve for x, which is a number. But in this particular situation, that is to say, when we're dealing with differential equations, we have derivatives in our equation, and these solutions are actually going to be functions. So when an initial condition is given that allows us to solve for c, we call these types of problems initial value problems. All right, so let me highlight that. Initial value problems. So what's the deal? The deal is because our equation involves derivatives, when we look at the solutions to a differential equation, we're not just going to get a single function, we're going to get a whole family of functions. But then if they give us some initial value or some initial condition, then we can actually solve for what C is. So I'm going to do an example here so that you guys can see what I'm talking about. Let's take a look at example 3. In example 3, they give me a differential equation. So I have a derivative, which is dy dx, equaling to some function f of x. So what I want to do is I want to try to find y. So, need to find y. So how am I going to do that? Well, the way I'm going to do that is I'm actually going to look for the antiderivative of sine of x. So y is going to be the antiderivative of sine of x, like this. In other words, we are taking the antiderivative of both sides. Okay? And that simply means I'm asking what function, when I take the derivative, do I end up with sine of x? So if you think about it, if you took cosine of x, that would not work because the derivative of cosine of x is actually negative sine x. So we actually need to put an extra negative in front there. All right. In addition to that, we know that if I added any constant, that's not going to affect the derivative. So I'm going to put a plus c, and when I take the derivative of negative cosine of x plus c, I still get sine of x. So that means that y is the antiderivative of sine of x. So because of that plus c right here, this means we have a family of functions. Okay. However, they give me this fact that y of 0 is equal to 3. So this is the initial condition. This is the initial value or the initial condition, right? So this is going to allow me to solve for what C is because I can just say I know that y of 0 is going to be equal to negative cosine of 0 plus C. And my goal is to solve for C. So we know that the left-hand side is going to equal to 3. That's what the initial value was, or the initial condition was. And we know that cosine of 0 is 1. So this will be negative 1 plus c. So when I solve for c, I'm going to get that c is equal to 4. So my final answer, the solution to this initial value problem, is y is equal to negative cosine of x plus 4. The reason why we call this an initial value or an initial condition is because they are giving me the function evaluated at 0. So if you think of this as time, time equal to 0 is sort of like your starting value or your initial value. Okay. All right, everyone. Take care.